So what happens then is that they're just changing the data. Well, there's a bunch of this research, similar research that's been done by very good science houses, yes, done over and over by very qualified physicists. One group is Park Labs at Princeton. Princeton's a very strong physics house, you know, good, smart people up there. And in their Park Labs, they have for the last 15 or 20 years been worried over problems that just don't make sense. They have a little robot, and the little robot is programmed to move randomly. It can go back and forth, left or right, randomly. They set the robot down in the middle of a big round table, about maybe a 4-foot diameter table, turn it on and let it, well, it just kind of wanders around in a little spot in the center, right? Because it's all random, as much one direction as the other. And they can let that robot do that for days. Never leaves the center of the table. They usually use graduate students. You get a graduate student to use their focused intent to bias those random distributions, and that little robot just wanders off and drops off the edge of the table. And they've repeated it and repeated it. They got to the point that they stopped doing it because it was too frustrating. They didn't have any idea why that was happening. They just knew it would work. Same sort of thing with other universities. Got the same sort of thing. They would do like the hospital patients. They had a radioactive source which would decay in any direction, random direction. They'd put 2 Geiger counters on either side of it, equidistant, and just let them collect. You know, when it happened to shoot out a particle, hit that Geiger counter, the Geiger counter would register a click, and so on. And they'd just let run until those Geiger counters each had maybe a couple of 100,000 clicks in them. And they take the data. They had done this, and some of the data was as much as 2 years old. They, again, just like the hospital patients, they would have people then use their focused intent to modify the data. And sure enough, if the people use their focused intent to look at the right Geiger counter and make it count more than the other one, which shouldn't happen, then it would. Or less, didn't make any difference. They could bias it either way. Now, it's not necessarily remarkable that you can do that experiment once. What's remarkable is that they can do that every time they try. See, so you can do that with 20 hospital groups. And all 20 of them, you can bias the way you want because the data is still in the future. Now, an interesting experiment was done with those hospital groups. They gave them another batch of data, but without telling them, they looked at the data first, did all the calculations of what the average hospital stay was. So they knew this time. This data wasn't in the future. That data had been measured. And they handed these people and said, you know, go do your thing and see if you can change the, you know, bias it one way or another. They couldn't. They tried, and because it didn't work, they tried again, and they tried again, and they couldn't move it a bit. Why not? Well, the data was already here. See, it wasn't in the future anymore. Now, that's exactly what quantum mechanics tells you to begin with. You know, the particle is a probability distribution until you measure it. Once you measure it, it's just a particle. It acts like a particle. Before you measure it, it produces diffraction patterns, which particles don't do because it's not a particle. It's a probability distribution. So what it tells you is that after you measure it, now it's in this reality frame, it's got to act like a particle in this reality frame. Well, once that data is here, you can't come up with something different because that violates, right, consistency. Turns out there's just 2 rules. One rule is that history has to be consistent. You know, we can't look out there now and see an ocean and turn around and look out there again and it's a forest. You know, it won't work. It's inconsistent. That's one thing. You need historical consistency. Once something comes into this reality and it's there, then it's there. It's a multiplayer game. You know, it has to be there for all of us. Then the other rule is that you cannot violate the rule set. I haven't told you yesterday what rule set is, but so I guess it's a good place to kind of back up and start over, and then we'll get back to rule sets. In a thumbnail sketch, here's the way reality works. Reality is consciousness. Consciousness is reality. We talk about brains, and Doc is right. You know, the brain does not create consciousness. Consciousness creates the brain. We are all products of this consciousness. We are all individuated units of consciousness ourselves. We are all part of the one consciousness. It starts to sound like metaphysics, doesn't it? We're all part of the one, right? And we are all netted in this consciousness net. We can all interact with each other, not just by talking and touching, but just with consciousness. We all communicate in nonverbal and not the usual nonverbal, but just with our minds. We communicate with each other all the time. You know, the New Agers call it vibes. You know, so I get good vibes or bad vibes, or I really like this person, but I've never met him before. I really dislike him, even though I never met him. So this is just the vibes thing. Well, the vibes is just, we communicate with each other all the time. Well, we're netted to every living thing, period. And that's not just people. You know, dogs and cats and chipmunks included in that. We're netted with everything. Everything that's alive here, you know, we're a part of it, it's a part of us. We are all one with this conscious system. So, anyway, the idea that this reality, as Fredkin said, is a simulation, now is a hard thing to swallow, right? That's tough, because here we are, we have these physical bodies, and we all, you know, deal in this physical world, and how is this a simulation? How are we just data? So let me give you a little sample of why that's not that big of a leap. What is this reality to any of you now? How do you measure? How do you know that this reality is here? Through your senses. That's it, right? Nothing else. Just through your senses. If you didn't have any senses, what would you be? Wouldn't be this reality, right? It would just be a dark void, no sound, no touch, nothing. You'd be a point of consciousness. That's all you'd be. Okay, so then what makes this reality? Well, we get light, say, for the sight. The light beam comes, gets focused by the lens, hits the retina, and then what happens? It turns into some digital data. You get a little electrical pulse. By digital, I mean discrete. It comes in units. It's not a continuous thing. It's a lump of something. That digital data, which is that pulse, that's the information. Right? Just like information on your computer, information coming in a telephone or anything else. It's just little pulses. Digital pulses carries the information. That information goes into your central nervous system, and what happens? It fires off neurons. Neurons are discrete. Again, digital data, little chunks. Neurons form patterns. Okay, so that's your reality is just digital information. Now, how do you get this reality out of that? You interpret it. You take that digital data, all those electrical signals, all those neurons and neuron patterns and all that motion on there, and you interpret that as this. That's all it is, digital data. That's your reality. Okay, now let's just take one more and say that it doesn't necessarily have to come through your senses. What if I could put some kind of helmet on you and stimulate your central nervous system in the exact same way it's being stimulated now? Identically. Same little pulses, everything. I could do that. You know, all your optic nerve would just be having the same pulses they're having on them right now. What would you see? It's exactly what you're seeing now. I mean, what's the difference? Data's data. Now, how do you tell the difference between those? You can't. It's impossible. Electric pulse, neuron patterns, doesn't matter where they come from, does it? And when you have that, it's data, you interpret it as this. Okay, so now how big a step is it to say we are just consciousness? We're getting a data stream. That data stream we interpret as this. So you see, something that was just totally crazy, actually is maybe not so crazy, because that's really the way it works here. We're just interpreting digital, discrete data. Okay, so that's the way your fundamental reality is. Now there's a whole lot of logical consequences to that, and things that do lead to the scientific explanation of how that water freezes like that, and how you have synchronicity, and why that robot walks off the table, and all that sort of stuff. Because when you realize that we are just information, this reality is nothing more than information. That's what Fredkin said. There's a couple of other scientists that come up with that same idea. We're just information. Now, let's see, where was I? That takes me, lose my place here. Okay, so that's kind of the fundamental concept. Okay. Take a lot of explanation for you to make good sense of that. In an information field, which is what consciousness is, so the consciousness system is all of it. We're just pieces of that consciousness system. As pieces of that consciousness system, we are entered into a virtual reality trainer. That's what this is. You know, we're in a virtual reality game, a multiplayer virtual reality game. And why are we here? To evolve. And why are we evolving? Because it's either evolve or die. The consciousness system itself has to evolve. Large, complex systems change. It's just, they have to change. They're very simple systems. They can be static, but large, complex systems always change. A system that changes has really two ways it can change. It can either evolve, grow, become more, or it can de-evolve, come apart, become less. So it's either evolve or die. So you have this consciousness system that has to either evolve or die. Okay, now how does it do that? Evolution is measured in terms of entropy. Entropy is a physics term. It's a concept of disorder. So you have high entropy, a lot of disorder. Low entropy, you have less disorder. Small amount of disorder. Okay, now a way of thinking of that also is that if you have low entropy, you have a lot of ability to do something, to do work. Physicists would say it's ability to do work. It's like applying an energy to something to make a change. An example, you have a bottle of gasoline. The gasoline can change things, particularly with the matches added, right? But that's very low entropy because all the molecules in that gas are all tightly bound together to form a liquid. Let it evaporate, it's all in the air. What can it do? Nothing. It's scattered all through the atmosphere now. It has no power anymore because it's random. Before it wasn't random, it was packed together in a liquid. Well, that's true of everything. Everything works on that principle. So we see that entropy is the way that a information system changes, evolves. Now, the information theory deals with entropy all the time. It's not just my association. Entropy as a measure of the amount of signal versus the noise, okay? The amount of content versus the randomness is a standard way of describing information. Okay, so if you have a big system like this and it's trying to evolve, it needs to lower its entropy by getting more organized. Well, how does it do that? It has to do that through interaction, through experience. The way it gets more organized, it interacts, you make choices. Those choices lead toward more coherency or less coherency. And to make a long story short, what that boils down to is the most profitable, the most optimum interaction that two beings can have is love. That's a building, constructing, helping, supporting connection. Okay? The opposite of that is fear. Fear is a tearing down, divisive. It's not a building or constructive. So now we come to the point that a larger conscious system evolves toward lower entropy states. That's its job, which means it evolves toward love, because that's the most constructive, most positive way. Positive, constructive, this all sounds like low entropy, right? Whereas divisive, coming apart, disintegrating, all of that sounds like high entropy. So here we have this larger conscious system, and its job, its mission, what it has to do to survive is to evolve toward love. Okay. Now, how does it do that? Through experience. How does it get experience? It's just a big conscious system. Experience with itself is all it can do. It's just this big system. Well, let's parallel process. Let's break pieces of it, give those pieces free will to interact, and let them interact. Now the possibility of novelty goes way up, because now you have two things interacting with each other. This one reacts or interacts to that one, which interacts to this one, and now we have things that are impossible just with something interacting with itself. Okay, so the larger conscious system has a strategy to evolve. It breaks itself into lots of pieces, and it lets those pieces interact with each other. And as those pieces interact with love, the system lowers its entropy and evolves. As they interact with fear, it increases entropy, it de-evolves. Okay. Now, that kind of tells us, what are we doing here? Well, we're those pieces of consciousness, you see. We're those pieces of consciousness. So what are we here for? We're here to evolve. We're here to lower the entropy of our system. We're here to become love. Now, there's a lot of ways you can say that. You can say we're here to lower our entropy. We're here to increase the quality of our consciousness. We're here for spiritual growth. We're here to become love. They all mean the same thing. That's what we're here for. And this reality was created for us to help us do that. It's a schoolhouse.